Hello, everybody. I'm going to spare you from me trying to speak French, so sorry for not trying it. When starting a new application, consistency seems really, really easy. Screens are often designed and developed closely together, and oftentimes just by a single designer and developer. So if there's any small inconsistencies, you just go through the application together and iron out those little issues. But fast forward a few years, and the situation often looks very different. New people joined, and others left. And as the design, as well as the features, evolved a lot. And so suddenly, you end up with 10 different buttons that are supposed to all look the same, but are slightly different. And different screens just look and behave very different because they were built at different times by different people. My name is Maria Neumayer, and I'm an Android engineer at Deliveroo. Deliveroo is a food delivery service, so we have 3 applications to build: a consumer, a restaurant, and a rider application. All of those 3 apps were built by 3 completely different teams, so while there were some similarities, like colors, for example, a lot of the components were very different, and so the designs were very, very different to begin with. But we wanted to have a unified design across all 3 applications. So how do you get from this mess to a consistent look and feel? And how do you ensure it actually stays consistent going forward? So we decided to tackle this problem by using a design system. So what's a design system? A design system is a set of visual styles, UI components, and guidelines that are used to build applications. These components can have rules or constraints. For example, a button can only have 3 different types: a primary, a secondary, or tertiary type. Or a specific text style can only be used for headings, for example. And all of these constraints and rules help with consistency, because they give people something to work with. You don't have to start from a blank canvas. They can also help with scaling, because both developers and designers can benefit from being able to use existing components and build screens with them. Creating new components can take a lot of time. There's a lot of back and forth between design and engineers to make sure it behaves and looks exactly how it's supposed to. But if you make it reusable, you only have to go through this process once and can then use it many times to come. A design system can also prevent duplication. Have you ever created a new style, like worked really hard on it to make sure it looks and behaves as it's supposed to? And then you create a pull request and somebody says, hey, this already exists somewhere else in the application. Or maybe worse, nobody actually notices, and suddenly you have 2 different versions of this style in your app that are probably slowly going to diverge, even though they're supposed to look exactly the same. With a design system, you have a single source of truth, so you don't have to go through the whole application to check that any style exists, or a style or component exists somewhere in the application. You just have to check the design system. So one design system you might be familiar with is material design. Before its introduction, Android was really known for its inconsistency. Applications would look and behave very different, and even within the operating system, there were many different behaviors. And there weren't many components to work with. You could only really work with the built-in components. And so every application ended up creating their own. So you had this navigation drawer, and every application built their own version of it, and they all looked and behaved quite differently. So they caused a lot of confusion to the user, because you had no idea what was going to happen when you actually clicked that navigation drawer icon. With the introduction of material design, this slowly changed. Google released a set of guidelines that could be followed and components that could be used. And with that, consistency slowly started to happen, with the applications actually following those guidelines. So chances are you're already using a design system. But what if you want to create your own? Where do you actually start? And how and when do you create components? And how do you then distribute them? Before you start, you need to make sure that both designers and engineers are on board with this. You need to work together on this. If only designers are working on it, you're going to create still custom styles for every screen. Or maybe some components are being reused, but a whole set of them should actually be the same. So if the design updates for a component, you're still going to have to go through each version of this component in your application and update them. And if only engineers use a design system, you're still going to get new custom component every time. So you either have to extend that component, or you can't use it and have to create a custom one. So you need to work on this together and be aware of what your design system actually supports. At Deliveroo, the original push for a design system came from our designers. They had to create 4 versions of every screen in the application: an iOS, an Android, a mobile web, and a desktop web version. So that's very time-consuming. And even though we had some shared components, there weren't many rules around them, so there were still a lot of custom components across the applications and inconsistencies. So simplifying this process made a lot of sense, and so a design system team was created. This design came up with a unified set of standards and components that were used across all applications, while still following platform conventions where it really matters, like navigation and input. So an application on Android doesn't feel like an iOS application, and still feels at home within its environment. This design system lives in Figma, so this is a tool similar to Sketch, but the difference is that both designers and engineers can use exactly the same tool and get the information they really need from it. So you get kind of guidelines and spacing and colors and what the different properties of the components are. You can also see the changes in real time, so you don't have to wait for a designer to actually finish work on the component. You can see what they're working on and then give feedback early. On the Android side, we mainly wanted to avoid recreating components across our 3 applications. Even before we had a design system, we realized that we had a lot of components that were actually shared across the 3 applications. So we decided to set up a shared repository. We already had a repository for our common architecture, but in there we also created a module, which we called UIKit. This name turned out to be pretty bad, because we could only use that on Android, because on iOS it would clash with the native iOS UIKit. So make sure you choose your name wisely. All the other platforms ended up with calling it a component library. But with this module living in a separate repository from our applications, there was a really clear separation between what is part of the design system and what is just an exception to the rule. So even if you only have one application, I really recommend at least keeping it in a separate module, so avoid blurring the line. It can also help with faster development, because you don't have to rebuild the whole application. You can only work within the module for your UI kit. But with this separation, a bunch of challenges came as well. We had to figure out how to actually integrate them within the application. We started off by using Git submodules, but that didn't quite work well for us. And we ended up creating a private Maven repository using Artifactory. So with this, you essentially publish your UI kit on Maven, and you integrate it like any other dependency. So you just need to add it to your Gradle file. You do have to tell it how to use the credentials and where to find it, so Gradle actually knows where it can find the repository. To publish changes, you just have to call this Artifactory publish command. And this actually happens on CI for us, so all you have to do is update the version, push a new tag, and you can use the latest version of the UI kit. And on the application side, you just update the version, and you can use all the new components. If you want to know more about how to set up your private Maven repository, Ron Moles, who spoke here yesterday, wrote a blog post about this a few years ago, so check it out. All right, so with this, this was very straightforward to use. And it also helped a bit with our build times, because the UI kit was used as a dependency, so we didn't have to rebuild every time we did a clean build in the application. But there was also a bit of an overhead with this. First, we had to think about versioning. We decided to use semantic versioning, like most other dependencies. So it's really easy to figure out how hard it is to actually update the UI kit. So a major version would be breaking changes, so you're going to have to update the application code as well. A minor change would be a new component, for example. And a patch version would be just little tweaks and fixes. So maybe the component changed slightly, but it doesn't really have much effect. It's just a visual change. We also kept a set of release notes to actually see what the changes were. So which component was created? Can I use it? Was that bug that I found already fixed? Now, these things might not be as important if you only have one application, but they can be really useful to figure out how your design system actually evolved. And if you have multiple applications, it's very useful, because not everybody will be able to update at the same time. Another issue with this separation was that you can't actually test the latest changes to UIKit easily. You don't want to publish a new version of the UIKit every time you want to test that this component works. But luckily, you can also publish to a local version of your Maven repository. So you just call this publish to Maven local command, and then add the Maven local repository to the list of repositories. So that's really useful if you just want to test a finished component to make sure it also works as expected in your application. But it's not really a viable option during development of a component. And for this, we created a component browser. So this component browser contains every component we have and every single combination they can come in. So you can really quickly test any changes to your design system and make sure that all versions are actually still working after you made any changes. It's also really useful to figure out which components exist and what they support. So if somebody new joins the team, you can quickly see what is available and what you can use. We want this to be really easy to use, and so you can actually have it as a separate standalone application to quickly iterate on new components, but also integrate it within the debug panel in our applications, so anybody can just quickly see which components are available, and you don't have to nag a developer to ask them for the component browser. So for this, we set up a separate module, which is just the component browser, and then another application module, which is just there to start this component browser. It's pretty much empty. Okay, so we now have the setup done, but how do you then actually go about creating components? One of the first components we created were colors and text styles. We used them for many years, so we had a set of brand colors and text styles that we used across the applications, so they weren't really anything new for us. But there weren't many rules around them, so a lot of exceptions were added, and the colors changed a little over time. So there were a lot of old colors in there that shouldn't be used anymore. So we wanted to have a fresh start. And even with something as simple as colors and text styles, we really wanted to get it right, because most other components would actually need these. Now, first, we wanted to make sure that our naming was really consistent across design and development. Have you ever asked a designer what color something should be, and they reply with a name, and you check in the application and you can't find it, so you ask for the hex code, and turns out you actually had that color, but it was under a different name. So we really wanted to avoid this back and forth. Now, we decided to have the same naming in Figma, where the design system lives, and in our UI kit. So for colors, each color has a name, like teal for this example, and then a number indicating the shade, like 100 in this example. And text styles, it was similar. First, we had the type. Is it a body or is it a heading? And then the size. And then optionally, you can also have the color and if it's bold. Okay, so we have the naming. So setting these up was quite easy, but we had to figure out how to actually use them in the application, because we had all those old styles hanging around. So we had to figure out how we could map the old ones to the new ones. And with colors, we really wanted to make sure that we stayed consistent. So our designers created this mapping between our old colors and the new ones. So we just had to essentially go through the colors one by one and replace them with the new versions. There were a few exceptions that weren't covered by this document, but we could just go through them together and figure out which new color to use, or if it should stay an exception. For text styles, we realized that the old and the new styles were actually very similar. So we didn't want to go through the whole application and replace all of the text styles. We only decided to use the new ones going forward. And whenever we were working on a screen, we would just update the old ones with the new ones. Replacing a whole component in the application can be quite a lengthy process, especially if it's used in many places in the application. So you only want to go through this process if you really have to. So weigh up the options with your designers to make sure that you actually have to do that. And for us, it meant we had to go through that process when we replaced our main font with a new one, because we didn't want to have two different fonts in the application. But because we already did all that previous work, it was a lot easier to replace the text styles with the new ones. Okay, so with colors and text styles defined, we were unlocked for many other components. And one of the first real components we created was a button. We had many buttons in the application, and most of them didn't really match the design system. They were close, but not quite. And even in the design system, this button component was really complicated. You had different types, a primary, a secondary, tertiary type. And then it could be enabled or disabled. It could be inverted, so on a dark background. It could have this red destructive state. It could be loading, or it could come with or without an icon. So you ended up with 42 combinations. And we wanted to make sure that all of these were behaving consistently. So in general, on Android, you have two different options for a component. You can either have a custom style or a custom view. Our old buttons were just styles, because it's the easiest way to quickly style a button. All you have to do is override a few properties, and it looks like it's your button, and not just the default Android button. So this is really flexible. And you can also add many exceptions. So if you want a special background on a button, you just override the background property. But there's also a downside, because it's so easy to add those exceptions. You're quickly going to end up with many, many different versions of it, with different paddings, different sizes, different text styles, but you all want them to be consistent. Styles can also be quite restrictive, on the other hand. You can't actually update a style programmatically. So if you want to switch from a primary to a secondary button, you actually have to update all the properties manually. So whenever you change your style, you have to make sure that you also update this code. And you might miss that. Another option is that you just have two views and switch back and forth between them. But it's also not a great idea. So we also had issues actually replicating this button component using just styles. One problem we had was the icon. We wanted the icon to be aligned next to the text, even when the button was full width. But if you're using a compound drawable on Android, it would actually align the icon to the side of the view instead. So we couldn't really use just this style, so we ended up with a custom view instead. With a custom view, you have full control over your component, so you can make sure you support exactly what you want in exactly the way you want it to. So you can be as restrictive or as flexible as you want to be. One issue we had with buttons with a custom view was third-party libraries. For our live chat feature in our consumer application, we used a third-party dependency called SoapBeam. But we wanted this live chat to feel as part of the application, so it shouldn't look and behave differently. You can style their views, but we couldn't replace their default Android button with our custom view. So we had to actually replicate our component as a style. So that's not great, but the downsides of the styles and the restrictions of it were a bigger issue for us. So whenever you create a component, choose what really works for you. Maybe you want to be more flexible, or maybe you want to be more restrictive and want to make sure that everything is consistent. And that can be different from case to case. And in this case, we opted for consistency. Next up is naming. As I mentioned before, we wanted to be consistent between the design system and our UI kit. But in the design system, it was just called a button. So that would kind of clash with the Android button. We didn't want to import that button and then accidentally import the Android button instead, and then crash the application. So we decided to add a prefix. And this is a convention we use going forward. So every button in the UI kit is easily identifiable as such. Okay, so now we have a name, and we know it's going to be a custom view. But we had to figure out how to actually structure this component. We wanted it to be really easy to use, and so you could configure it both in XML as well as in code. So we ended up adding a bunch of custom attributes. And again, the naming is exactly the same as you can find in Figma in the design system. So we came up with the following attributes. There's the text, an icon, a type, and then a bunch of Boolean values indicating if it's inverted, loading, or enabled. Now, these are quite a lot of properties you have to set. So we also came up with some sensible defaults. So if you want a button that is enabled, primary, with no inversion, no loading, and no icon, you just set a text. We also allow this to be configured by theme by using a style attribute. So if you have a dark screen, for example, you might want your buttons to be inverted by default. And you can do that by just using this UIKit button style. Programmatically, it's very similar. You just set a property, and the button updates. So this matches, again, exactly what you can do in XML. But apart from that, we don't really allow any other additional styling. And that's for two reasons. First, it forces consistency. It can be really, really tempting to give one button a really special look and feel. But if you're not careful, you're going to end up with many different special cases, like we did before. So we want it to be more restrictive. And if you're more restrictive, you need a really, really good reason to break the rules, because it either means creating a new custom component or updating the design system. The other reason is it simplifies the component. You don't really have to think about what happens if you change a background and then update the type. So do you have to change the background because the different type has a different background, or do you keep it because it was overridden? So if you don't really allow that, you don't have to worry about that. That doesn't actually stop somebody from doing it programmatically, but it's going to take a lot more effort to do so. And you might have run into issues like this with material design components. Maybe you tried to set a multi-line title on a collapsing toolbar, or maybe you tried to show the tab titles of a bottom navigation view when there were more than 3 tabs, where it would hide it by default. Those things are surprisingly hard, because the components actually don't allow it. But often there's a reason for that, and that is consistency. Now, you're going to have a smaller likelihood that you run into these issues if you control both the component and the application. But both designers and engineers need to be aware of the limitations. And ideally, the same limitations should exist in your design system and your UI kit. So both designers and engineers can do the same things to their components. But sometimes it does mean adding exceptions. One component we have is this tab bar. And it's just a default tab bar, but with a bunch of custom behavior and UI. So we actually had to add quite a lot of code to this. On the Writer application, we wanted to have an additional visual cue on a tab to indicate that you couldn't actually select something within this tab, so you couldn't book any sessions in there. This wasn't actually part of the design system, so we didn't want to add this to the component itself. But we also didn't want to not use this component, because it would end up having to copy this whole component, and it would probably get out of sync quite quickly. So we decided to allow a bit more customization on this component, so applications can override the behavior a bit and set this resting text color for each tab. And this also unlocks other use cases. Maybe in a different case, we want to highlight the tab specifically. But this specific use case isn't part of a design system, so it's not really, we didn't really break the rules. Okay, so I talked a lot about components, but when do you actually create a new component? We don't have a dedicated team on the Android side for building these UI components, so we only wanted to create them when we really needed them. So is it actually easier and faster to use an existing component than to just style this view? Or is consistency actually really important? And finally, are there actually multiple use cases for this? And if so, then yes, create a new component. And you might already have a different version of this in your application. It might not be as flexible enough, it might not support all the different use cases, but you still have a good basis that you can then extract and add all the different use cases to it. And for us, in a lot of cases, a component existed in one application that was needed in another one. So we could actually work on those components together and collaborate a lot more across the 3 applications. But even if a component doesn't exist yet, it can still be useful to create it within your application with a specific use case in mind first, because you don't have to worry about all of the different cases, and you can only worry about that one specific use case and figure out how you want to build that and then extend it. But components also don't really stay static. Your designs are going to evolve, and components are going to change eventually. So how do you update them? Some changes are just going to be visual, or little additions to a component. So these are easy to do. You just update the component, the applications update, and everything behaves as it's supposed to do. But others might be a bit more complicated, and actually require code changes in the application. In our button component, we had this destructive type. that lived alongside the primary, secondary, and tertiary type. So a button could either be one of the four. But we wanted to change this, so the destructive type could actually live alongside of these three. So you could have a destructive tertiary style. So this button is used in many, many places. So we didn't want to just suddenly break it for everybody. And we didn't want to update all of them at once, because it's going to take quite a long time. But we wanted to make it straightforward to update. So we didn't want to remove this type, because that would mean breaking change and a major update. So we ended up deprecating this type property. So we could now gradually migrate to the new destructive property instead of the type. And then next time we're doing a major bump, we can just clean this up and remove them. And hopefully by then all of the usages will be gone. But for that, it should be quite easy to spot that you're using this this deprecated property. So we decided to use this deprecated property annotation. So whenever you build, you're going to get a warning that you're using this deprecated code. And also whenever you're actually using it, you're seeing it instantly. And we're also adding a logging. So whenever you use it, you're going to see this in your logs that, hey, you're using this deprecated property. So all of those things should make it easy to spot those issues. And then when we clean it up, we're actually, internally, we're actually matching this destructive type to the property instead. So you have the primary type with the destructive property. So within the component, we don't have to worry about keeping those two different versions, maintain those. And then when we remove it, we just have to remove this if statement, and it's cleaned up. Our components became more complex as time went on. So we started with just textiles and colors, then created single components, and then compositions of multiple components like this empty state. And that's quite a natural progression, and it's called atomic design. With atomic design, you have 5 distinct levels for your components. You start off with atoms. These are the smallest blocks, which you can't divide any further, like a button, for example. Now you might think, hang on, a button has a background and it has a text and all of those things, but you can't use a button without them, so it's still an atom. And then you have molecules. So these are several atoms combined. One example might be a row item, where you have an icon, a title, a subtitle, and maybe a checkbox on that side. These can all be standalone items, but together they form a molecule. And then you have organisms. These are more bigger and more complex components, like a dialogue, for example. And then templates. These are the XML layout of your activity. So they're the layout without any content. And finally, you have pages. So these are the templates with the real content. So they're the end result that the user actually sees. So from level to level, you get more complex until you end up with your final screen. In a design system, you're only going to go up to organisms, because templates and pages are for specific use cases. So if you want to know more about atomic design, there was a talk about this last year at DroidCon Italy by Yaya Baramoglu. So check it out. Now, there's one component I didn't talk about yet, and that is icons. Icons were probably one of the most complex things for us to figure out. We had a full icon set from our designers, but we had difficulties actually integrating them within the applications. Design did a lot of the hard work for us. They converted the SVGs into the Android vector format. So we already had the right format, but we couldn't really figure out how to then integrate this list of icons in our applications. We started off by just copying the files, and that was good because it was really flexible. We could create a different version for each tint we needed and each size we needed, and then just set it as our compound drawable, for example, where tinting wasn't that easy until recently. But it also was really annoying, because once you copied this icon, you couldn't easily update it. So whenever the icon changed, we would have to actually manually go through all our icons and update them. So they quickly became out of date. And the copying turned out to be quite tedious and frustrating. So we really wanted to find a solution for this issue. We already had the full list of icons exported, so we didn't really have to worry about that. The icons actually lived in the design system repository, so they were already checked in Git, and we could work with that. So we would end up essentially creating a small module around this list of generated icons, and then publish a version of the UIKit icon set on our factory. So all you have to do when the icon set updates, we would automatically publish a new version on CI, notify us in Slack that there's a new version, and you can integrate it like any other dependency. So to get the latest changes, you just update the version. So this is really, really easy to use and really makes using icons a lot easier. We do have to now tint and resize them manually, but maybe in the future we could actually have a separate version for each of our tints within this icon set as well. But no more updating and copying icon, so that's great. This is definitely something I wish we'd done earlier, because now we have to actually update all our existing icons with this new version. So that's going to take a while. So we now have a pretty good foundation, but there's a lot more components we need to build and a lot more inconsistencies to iron out. But we've come a long way from about a year ago, when nothing like this existed. So what's next? One thing we're not really good about is making sure that our components stay up to date. For example, this change I talked about with the button, this change happened ages ago, but we never really did it. So generally, our design team actually writes an update message about the latest changes, but we might miss this, and then so we either notice in Figma ourselves, or a designer checks the application and sees that the component doesn't look and behave as it's supposed to anymore. So while we're working together on this, while we're creating components, we're not really working together that much once we're done with it. So we need to really work a lot closer together. Our web engineers have a regular catch-up with the design system team every 2 weeks, where they talk about the latest components, both from the design and the development side. So this is something we might want to do as well, because it also helps us actually creating new components, because you don't want to go to this meeting every 2 weeks and be like, well, we didn't do anything, so. Another thing we might want to do is that the design system team creates GitHub issues in our repository. So even if we don't spot that right away, we can see exactly what the changes we have to do, and then make them whenever we have time. But these changes are still manually, and some things should actually pretty much happen automatically. Colors and text styles, if they change, you don't want to go through them and update them manually. And there's a thing called design tokens, which Salesforce uses heavily. So these are essentially your core styles, like your colors, text styles, some of the dimensions. And these can get generated into a JSON format. So whenever this style changes, the JSON gets updated, and then spits out a platform-specific version. So on Android, you would get XML styles and resources. And on the development side, you just pull the latest changes and don't have to update them manually. So this is very similar to what we're doing with icons. So I'd love to be able to get to something like this with more things. Another thing we might want to do is modularize our UI kit. Currently, we have most of the common components, but we might have some more specific ones, maybe for one application or for one feature. But we don't want to increase the application side of all our applications unnecessarily. And also don't want to slow down our builds in the UI kit, which are currently really, really fast, by adding lots of different components. So modularization can help with both of these, because you can only integrate the components that you actually need in the application, but also build all the components parallel. So even a year long, we're still very much at the beginning of our design system. But it's been very useful for consistency and speed of development. It got us a lot closer as a team, both within the Android team and with our designers, because we could work on these components together. Creating components is surprisingly hard. You have to consider a lot of different use cases, make sure your language is consistent, and the components are actually easy to use. But in the end, it is really worth it. So I hope this could help you get started on your design system. Thank you. Any questions? No.
I Thank you for the talk. What about localizations? Can you do some similar for localizations?
Localization?
Yeah.
We haven't really tackled that in our design system yet, so we're still just localizing strings within the application. We currently don't have anything that is part of the design system for strings, but yeah, in the future we're going to have to figure out how to do that. But yeah, we support right to left in the component and everything like that, so we do support this, but all the texts and things like that come from the application.
One notice from your talk, you're using view instead of button, so check accessibility because they behave different.
Sorry?
Check accessibility because they behave different.
Yeah, so we're currently not, to be honest, we're not really great with accessibility right now. We kind of support the basics, but we haven't spent a lot of time on really going through our application and making sure everything is accessible, sadly. But yeah, I think especially on the website, they're making sure that all the components are accessible. But currently, we're not entirely sure with icons and things like that how to do that. But yeah, we're making sure that the content description and that is ignored if it's not important.
Hello. Do you have a specific team who is working on the design system, or is it the responsibility of your 3 teams?
Yeah, so on the design side, we have a team that it's called Design Ops. So they're kind of working on the design system as well as making other things easier for designers. We have been talking about having a mobile platform team, for example, that would potentially also work on the UI kit, but right now it's just a responsibility of us. So whenever we need a component, we're creating it. Anybody else? Cool. I'll be down here, so if anybody has questions, feel free to come. Thank you.